For thousands of years, when people looked up at the endless canvas of the night sky, they didn't just see random specks of light, they saw epic stories, divine messages, and intricate designs woven into the darkness. The same stars that guided ancient sailors and inspired mythmakers still shine down on us today, but now we see them through a different lens. Hidden within those constellations and celestial clusters are 32 extraordinary patterns, nature's own masterpieces that reveal a secret symphony written across the cosmos. These aren't just shapes, they're clues to something deeper, a hidden order that connects the dance of planets, the birth of galaxies, and even the rhythm of life itself. What if I told you that by learning to read these cosmic blueprints, you could unlock a new way of seeing the universe? This journey will take us from the myths of the ancients to the cutting edge of astronomy, showing how star patterns hold answers to questions we're only beginning to ask. The sky isn't just above us, it's speaking to us, and if we listen closely, we might just understand what it's trying to say. Picture this: billions of stars scattered across the cosmos, each one drifting through space like a single note in an endless symphony. But in that vast, seemingly chaotic expanse, hidden patterns emerge. How it all comes down to gravity, nature's invisible hand, pulling stars into orbits, clusters, and breathtaking formations that stretch across light years. Just as a composer arranges notes to create harmony, the universe sculpts these celestial designs through forces we're only beginning to fully grasp. Take constellations, for example, those familiar shapes we trace in the night sky. While they may look like close-knit groups, many of those stars are actually light years apart, only appearing connected from our viewpoint. The real cosmic architects are star clusters, where hundreds or even thousands of stars are born from the same colossal cloud of gas, bound together by gravity like a stellar family. And then there are galaxies, spiraling masterpieces where billions of stars dance in precise orbits around supermassive black holes, creating structures so immense they defy imagination. Astronomers like Galileo first shattered the illusion that these patterns were fixed, proving stars move and evolve over time. Later, Edwin Hubble showed us galaxies beyond our own, revealing a universe far grander than anyone had dreamed. Today, telescopes like James Webb are peeling back even more layers, spotting newborn stars nestled in glowing nebulae and tracing faint threads of dark matter that shape these cosmic tapestries. Yet here's the beautiful twist: science and myth aren't rivals here. The same patterns that astronomers measure with equations were once seen as gods, beasts, and epic tales written in the stars. And perhaps that's the true magic, that in decoding how these formations work, we're not just uncovering universal laws, but also rediscovering the stories humanity has always told when gazing upward. The sky isn't just a laboratory, it's a canvas where science and wonder meet. Long before telescopes or star charts existed, people around the world looked up and saw more than distant suns. They saw reflections of their own lives, fears, and dreams painted across the heavens. The Greeks envisioned Orion, the mighty hunter, forever chasing the Pleiades sisters through the sky, while the ancient Egyptians saw the same constellation as Osiris, the god of resurrection. Indigenous cultures from the Americas to Australia wove the Milky Way into sacred stories, sometimes a river of souls, other times a celestial pathway for ancestors. These weren't just tales, they were survival guides. The rising of Sirius signaled the Nile's flood to Egyptians, and Polynesian navigators used the Pleiades to time their voyages across the Pacific. What's fascinating is how these myths often stumbled upon truths later confirmed by science. The Maori story of Taine separating his parents, Earth and sky, mirrors our understanding of planetary formation, gravity pulling matter into structured worlds. The Greek legend of Callisto, transformed into a bear and placed among the stars, eerily matches the way constellations shift over millennia due to Earth's wobbling axis. Even the Milky Way's name comes from Greek mythology, where it was spilled milk from the goddess Hera, yet today we know it as our galaxy's edge, a swirl of billions of stars. So were these myths just imaginative guesses, or did they capture something deeper? Perhaps they were humanity's first attempt at science, using stories to explain patterns too vast to comprehend. But not all cosmic designs fit neatly into legends or equations. Some formations refuse to be explained, hinting at mysteries neither myth nor science has fully unraveled. But while myths and science have decoded many celestial wonders, the cosmos still holds patterns so bizarre they defy all our explanations. Stretching across the vast expanse of space are formations that shouldn't exist, structures so massive, so unexpected, they make astronomers question everything we thought we knew. Take the Fermi Bubbles, colossal gamma-ray emitting balloons expanding from the Milky Way's core, each one towering 50,000 light-years tall. No one knows what cosmic event blew them into existence. Was it a burst of star formation, a long-ago eruption from our galaxy's supermassive black hole? Or something even stranger? Then there's the Great Attractor, an unseen force pulling thousands of galaxies, including our own, toward a single point in space with the mass of 100 quadrillion suns. Dark matter, a supercluster hidden behind the Milky Way's dust. The sheer scale of this mystery rewrites the rules of gravity itself. And let's not forget Boyajian's star, flickering erratically as if something, maybe planetary debris, maybe artificial megastructures, is blocking its light in ways no natural phenomenon can explain. Theories abound, from collisions with invisible dark matter halos to civilizations harnessing stellar energy, but the truth remains maddeningly out of reach. What's wild is that these aren't just scientific footnotes, they're glaring contradictions to our models of the universe. If the Fermi Bubbles were sculpted by black hole activity, why don't other galaxies show the same scars? If dark matter powers the Great Attractor, why does its pull seem to warp space-time differently than predicted? Every unanswered question is a crack in the foundation of modern astrophysics, hinting that the cosmos might operate by rules we haven't even imagined yet. Yet amid the chaos, there's a strange beauty to these cosmic anomalies. Like abstract art, they challenge us to see beyond the expected, to find meaning in the unexplained. And perhaps that's the real revelation, that the universe's most stunning patterns aren't just problems to solve, but reminders of how much wonder still awaits beyond the edges of our understanding. Hidden within the swirling arms of galaxies and the orbits of planets lies a secret language: mathematics. Not just any numbers, but the same elegant sequences that appear in sunflowers, seashells, and even our own DNA. The cosmos adores symmetry, and nowhere is this clearer than in the Fibonacci sequence, where each number builds upon the last in a perfect spiral. Look at a spiral galaxy like Messier 74, and you'll see that same graceful curve echoed across 100,000 light-years. Even Saturn's polar storm, a churning hexagon wider than Earth, follows geometric rules we recognize from honeycombs and snowflakes. What's breathtaking is how these patterns transcend scale. A tiny Nautilus shell grows in the same logarithmic spiral as a galaxy because the laws of physics favor efficiency, whether constructing a microscopic structure or shaping a nebula. The golden ratio, roughly 1.618, appears in the spacing of planetary orbits, the branching of cosmic dust filaments, even the pulsing light of variable stars. It's as if the universe has a favorite blueprint, returning to these proportions again and again. Artists have sensed this harmony for centuries. Van Gogh's Starry Night doesn't just depict chaos, its swirling skies mirror turbulent star-forming regions, a phenomenon astronomers now call Kelvin-Helmholtz instabilities. Was he intuiting cosmic truths or simply tapping into the same patterns that shape galaxies? Even Renaissance architects like Da Vinci embedded the golden ratio into their designs, chasing a beauty they felt was divine. So, is the universe an artist? Perhaps a better question is, are we, in our search for meaning, merely recognizing the brushstrokes of a grander design? Every spiral drawn, every symphony composed might just be our way of echoing the rhythms written into the cosmos itself. And in that echo, we glimpse something extraordinary, that the boundary between science and art is far thinner than we ever imagined. Even in silence, the cosmos sings. Over 2,000 years ago, Pythagoras stood beneath the night sky and heard something no one else could: a celestial harmony. He believed each planet, as it traced its orbit, vibrated with a unique pitch, blending into a perfect chord called the music of the spheres. Though his idea seemed mystical, he wasn't entirely wrong. Centuries later, Johannes Kepler took up the torch, mapping the planet's movements to musical notes in his Harmonices Mundi. To him, the solar system wasn't just mechanics, it was a choir, whispering a divine melody only mathematics could decode. Fast forward to today, and we've found a way to listen. Stars don't hum in audible tones, but they do pulse with electromagnetic vibrations, radio waves, X-rays, ultraviolet ripples, all coursing through space like an interstellar symphony. NASA sonification projects translate these waves into sound, stretching telescopic data into eerie, ethereal melodies. Listen closely to the song of a pulsar, and you'll hear rhythmic beats like a cosmic drum. The Whirlpool galaxy's spirals become a haunting choir, its pitch rising and falling with the density of its stars. Even Saturn's rings emit chirps and clicks, captured by the Cassini spacecraft as it skimmed their icy edges. What's striking isn't just the beauty of these sounds, it's their precision. The same physics that tunes a violin string also governs a star's oscillations. When our sun vibrates, its surface heaves in waves that reveal its inner structure, much like a bell's chime betrays its shape. Astronomers call this astroseismology, and it's how we've uncovered hidden details about stars' ages, compositions, even their futures. Could this cosmic orchestra shape life itself? Consider Earth's tides pulled by the moon's gravity in rhythms mirroring lunar orbits, or the way solar flares erupting in magnetic crescendos disrupt satellites and power grids. Some scientists speculate that early life may have emerged in tidal pools, rocked by the moon's slow, rhythmic tug, as if the universe itself provided the tempo for evolution. Perhaps Pythagoras was onto something deeper than metaphor. The universe doesn't just have patterns, it is pattern, a vast composition where gravity, light, and time are the notes. And in hearing its music, we're not just observers, we're part of the chorus. Among the countless stars dotting the cosmos, some shine with a special promise, not just light, but the potential for life itself. Astrobiologists call these the Goldilocks stars, not too hot, not too cold, but just right to cradle planets where liquid water, and perhaps life, could exist. Picture a star like our Sun, steady and stable, with planets orbiting at the perfect distance. That sweet spot, the habitable zone, is where water stays liquid, where chemistry can dance into complexity. But here's the twist, it's not just about distance. The star's temperament matters too. A hyperactive young star might blast its planets with lethal radiation, while an aging red giant could scorch worlds that were once safe. Recent discoveries have turned up thrilling candidates: exoplanets like Kepler 186f, Earth's cousin orbiting a dimmer sun, or TRAPPIST-1b rocky worlds huddled close to their cool dwarf star. Even more astonishing, the James Webb Space Telescope has sniffed out water vapor and organic molecules in distant atmospheres, hints that the ingredients for life are scattered far beyond our solar system. But what forged those ingredients? Look no further than the violent end of massive stars. Supernovae are the universe's ultimate alchemists, forging carbon, oxygen, and iron in their cores before scattering them across galaxies in explosive death throes. Every atom in your body was once inside a star that lived, died, and seeded the cosmos anew. So is life out there. The numbers suggest it's nearly inevitable. With billions of galaxies, each hosting billions of stars, the odds tilt toward a universe teeming with possibilities. But if life is part of the cosmos's score, where do we fit in? For the first time in Earth's history, a species has begun reading that score using telescopes to decode planetary harmonies, sending signals into the void, even dreaming of stepping onto alien worlds. We're not just passive observers, we've become active participants in the universe's grand story. And if life truly is written into the fabric of reality, then the search for it isn't just science, it's a conversation with the cosmos itself. From the moment early humans first looked up and saw constellations guiding their harvests, our species has had an unbreakable bond with the stars. Ancient cultures didn't just observe celestial patterns, they built their lives around them. Stonehenge's towering stones align perfectly with the summer solstice sunrise, while Mexico's El Caracol Observatory tracked Venus's path with astonishing precision. These weren't mere monuments, they were calendars, compasses, and temples to the rhythms of the cosmos. Farmers planted crops by the Pleiades' rise, navigators steered ships under Polaris's steady light, and entire civilizations timed their rituals to eclipses. The stars weren't distant lights, they were collaborators in human survival. Fast forward to today, and that dialogue has only deepened. Projects like SETI scan the skies for extraterrestrial signals, transforming starlight into potential conversations. Space telescopes like Hubble and Webb act as cosmic interpreters, decoding the universe's whispers into breathtaking images. Even our smartphones contain technology GPS that relies on satellites triangulating positions using star-like pulsars. Every Mars rover, every exoplanet discovery, every radio signal beamed toward distant stars is a continuation of humanity's oldest conversation. But here's the most profound shift. We've moved from reading the cosmos to writing back into it. Consider the golden record aboard Voyager, carrying human greetings and music into interstellar space, or the Arecibo message, a deliberate cry of "We're here" beamed toward a star cluster. These aren't just scientific endeavors, they're acts of cosmic kinship, a way of saying we're ready to be part of a larger story. So how can you join this legacy? Step outside on a clear night and trace Orion's belt with your finger. You're using the same map that guided Bronze Age traders. Download an app that identifies constellations in real time, turning your backyard into a planetarium. Participate in citizen science projects like Globe at Night, tracking light pollution's effect on our view of the Milky Way. The universe's patterns aren't locked away in observatories, they're overhead, waiting for anyone curious enough to look up and listen. The stars shaped our past, now they invite us to shape the future. There's something about standing beneath an open sky, away from city lights, that makes the universe feel deeply personal, almost sacred. For centuries, cultures have turned to the stars not just for navigation or science, but as a mirror for the soul. The Maori of New Zealand saw the Milky Way as Te Ikaroa, the celestial canoe carrying departed ancestors. Tibetan monks still use star maps in meditation, aligning their breath with the slow turn of constellations. Even modern astronauts describe an overwhelming sense of unity, the overview effect when seeing Earth suspended in the cosmic dark. It's as if the stars strip away distractions, leaving only awe. You don't need a telescope to feel this. Try lying on your back in a quiet spot, letting your eyes adjust until the sky isn't above you but around you. The faint glow of the Milky Way, the occasional streak of a meteor, it's nature's original mindfulness exercise. Ancient Greek Stoics called this astral contemplation, a practice of grounding oneself in the vastness to put daily worries into perspective. Modern science backs this up. Studies show stargazing lowers cortisol levels, likely because it triggers our innate sense of wonder, the same feeling that captivated our ancestors. City dwellers, don't despair. Light pollution might veil the cosmos, but even urban skies reveal treasures if you know where to look. Venus often pierces through the glow as a steady evening star, and Orion's belt is visible from most sidewalks. Apps like Skyview use augmented reality to overlay constellations on your phone's screen, turning a balcony into a portal to the heavens. For a deeper reset, seek out dark sky parks, protected areas like Death Valley or Scotland's Galloway Forest, where the night unfolds in its full glittering glory. Now imagine taking that quiet connection a step further. What if you could read the sky like a map, not just admire it? Start simple. Learn just one constellation per night. Spot the Big Dipper, then follow its handle's arc to Arcturus, a golden giant older than our solar system. With a cheap pair of binoculars, you'll resolve the Pleiades from a fuzzy patch into a cluster of newborn stars. It's not about memorizing charts, it's about building a relationship one star at a time. The cosmos doesn't rush, and neither should you. After all, the stars have been waiting billions of years. They'll meet you right where you are, of course. Stepping into the cosmos doesn't require a PhD, just the right tools to unlock what's already overhead. Think of the night sky as a vast, ever-changing puzzle, and the gadgets at our fingertips today are like cheat codes for deciphering it. A decent pair of binoculars, for instance, can reveal Jupiter's moons or the craters on our own lunar neighbor, while a beginner-friendly telescope, like a 6-inch Dobsonian, opens up galaxies and nebulas invisible to the naked eye. But you don't even need hardware to start. Apps like Sky Safari or Stellarium turn your phone into a portable planetarium, overlaying constellations in real time as you point your camera upward. Star maps, those ancient paper guides, are still invaluable. Here's how to read one. Hold it overhead with north aligned to true north, and suddenly those cryptic dots transform into Orion's sword or Scorpius's curved tail. Timing matters too. Catch the summer triangle high overhead in July, or wait for winter to see Sirius, the sky's brightest star, blazing near Orion. For the most immersive experience, plan around the new moon, when faint cosmic details shine brightest against the unpolluted dark. But what if you could do more than just observe? Platforms like Zooniverse let anyone join real astronomy research, classifying galaxy shapes or spotting exoplanets in telescope data. There's even Globe at Night, where simple observations of visible stars help track light pollution's creep. It's science without a lab coat, where every set of eyes contributes. Now, imagine turning these tools toward the first of those 32 hidden patterns, a celestial design so elegant, it bridges myth and physics. Picture the Northern Cross, part of Cygnus the Swan. It's 5 stars forming a crossbeam that points directly to the Milky Way's heart. Sailors once navigated by it, but modern astronomers see something deeper. A signpost to a supermassive black hole, its gravity bending starlight into a cosmic fingerprint. This isn't just a shape, it's a roadmap written in the stars. Look up on any winter night, and one constellation instantly commands attention: Orion, the hunter, with his unmistakable belt of 3 bright stars. But this isn't just a striking pattern, it's a cosmic Rosetta Stone linking ancient myth, architectural genius, and celestial navigation in ways that still baffle scholars today. Those 3 stars, Alnitak, Alnilam, and Mintaka, form a perfect straight line so precise, it's mirrored on Earth in the pyramids of Giza. The Great Pyramid's air shafts align with Orion's belt stars, as if the builders encoded celestial coordinates into stone. Was this coincidence, or did a lost civilization possess astronomical knowledge rivaling our own? Egyptians saw these stars as the gateway for pharaohs' souls to ascend to the heavens, but they weren't alone. Polynesian navigators steered canoes across the Pacific by tracking Orion's rise, while the Maya tied its movements to sacred calendars. Even today, sailors use Orion's belt to orient themselves. The lower star, Alnitak, points directly south in the northern hemisphere. There's a reason this constellation transcends cultures. It's one of the few patterns visible from every inhabited part of the globe, a universal landmark stitched into humanity's collective sky. Yet Orion's secrets run deeper. Nestled below his belt lies the Orion Nebula, a stellar nursery where new suns ignite, visible even to the naked eye as a faint smudge. Through telescopes, it explodes into swirls of pink gas and infant stars, a glimpse of creation itself. Then there's Betelgeuse, the red supergiant marking Orion's shoulder, a ticking bomb set to explode as a supernova anytime in the next 100,000 years. When it does, it'll outshine the moon for weeks. So was Orion's belt just a handy guide for ancient architects and sailors? Or does its alignment with the pyramids hint at something more profound? Perhaps the truth lies in the stars themselves. Every time we gaze at this constellation, we're seeing the same cosmic hunter that watched over humanity's first astronomers. And if Orion holds this many mysteries, imagine what other patterns might conceal. Twinkling like a handful of sapphires tossed onto velvet, the Pleiades cluster has captivated skywatchers for millennia. These aren't just random stars, they're a true cosmic family, born from the same collapsing gas cloud roughly 100 million years ago. Their striking blue hue isn't an illusion, it's physics in action. Unlike our yellow sun, these stars burn fiercely hot, their intense radiation emitting shorter, bluer wavelengths. Surrounding them, wispy reflection nebulae, celestial cobwebs catch and scatter their light like diamond dust. Modern telescopes reveal the cluster's full splendor, nearly 1,000 stars, though most cultures historically saw only 6 or 7. The reason? Our eyes conspire with mythology. The seventh sister may have faded from view over centuries, or perhaps ancient observers encoded a deeper story in that absence. Across the Pacific, the Maori saw the Pleiades as Matariki, whose first rising marked their new year, a signal to plant crops. Greek mythology told of 7 sisters fleeing Orion, turned into stars to escape his pursuit. In Japan, they're Subaru, immortalized in both folklore and car logos. What's remarkable is how these diverse cultures independently fixated on the same cluster, weaving it into calendars and creation myths. Science now confirms their intuition. The Pleiades' position does correlate with seasonal shifts, making it a celestial clock long before telescopes existed. Astronomers treasure this cluster for different reasons. Its youth and proximity, just 440 light-years away, make it a laboratory for studying stellar adolescence. By tracking the Pleiades, we've learned how stars spin, how planetary systems form, even how cosmic magnetic fields sculpt their surroundings. The European Space Agency's Gaia mission recently used the cluster to test gravity's behavior on interstellar scales, probing mysteries that could redefine physics. But the Pleiades offer more than data. They're a bridge between eras. When you spot them, best seen in winter's shoulder months, you're witnessing the same celestial clock that guided Polynesian voyagers to Hawaii and told Greek farmers when to harvest. And if you listen closely to the silence between those stars, you might just hear the universe whispering its next secret, one that involves a far older timekeeper ticking patiently in the northern sky. Here's your next segment following the requested guidelines. If you've ever checked your horoscope, you might assume the constellations behind it are fixed in place, but the sky has a mind of its own. The zodiac signs we associate with birthdays today are actually misaligned with the real stars by nearly an entire month, thanks to a slow celestial wobble called precession. Imagine Earth as a spinning top that's slightly off balance. Over millennia, its axis traces a lazy circle in space, completing one full loop every 26,000 years. This means the stars we see today, like Aries or Scorpius, weren't in the same positions when the Babylonians first mapped the Zodiac 3,000 years ago. By the year 14,000, Orion will dominate summer skies, while Polaris, our current North Star, will hand off its title to Vega. Ancient astronomers were surprisingly attuned to this drift. The Maya built observatories to track Venus's shifting path, while the Egyptians aligned the Sphinx with Leo's position during the Age of Taurus. Even Stonehenge's stones subtly encode this cycle, marking solstices that creep backward through the zodiac over centuries. These cultures weren't just stargazing, they were timekeeping on a geological scale, using the heavens as a clock with gears that turn once every 26 millennia. So does this make astrology obsolete? Not exactly, but it does reveal a cosmic joke. The Pisces you were born under today actually aligns with Aquarius's stars, a discrepancy that'll only grow wider. Yet there's profound beauty in this drift. It turns the zodiac into a grand metronome, ticking so slowly that civilizations rise and fall between its beats. Time itself stretches and bends here, reminding us that even the stars are travelers in an endless dance. And dance they do, just not in the orderly zodiac wheel we imagine. Out beyond our solar system, galaxies whirl in spirals so vast they make Earth's wobble look trivial. Their patterns aren't bound by precession, but by gravity's relentless pull, sculpting shapes that defy both time and human calendars. Few sights in the cosmos are as hypnotic as the Whirlpool galaxy, its spiral arms unwinding across space like liquid starlight, each curve a flawless testament to gravity's artistry. Catalogued as Messier 51, this celestial whirlpool isn't just beautiful. It's a master key to understanding how all spiral galaxies, including our own Milky Way, take shape. Unlike the jagged shards of irregular galaxies or the bland orbs of ellipticals, the whirlpool's arms are textbook perfect, tracing a logarithmic spiral so precise it could have been drawn with a cosmic compass. Zoom in, and those arms reveal their secret, their stellar nurseries on an epic scale. Dark lanes of dust weave between blazing blue clusters of newborn stars, while pink hydrogen clouds glow like embers, each feature a signpost in the galaxy's life cycle. Gravity choreographs this dance, sending density waves rippling through the galactic disk. Just as traffic jams form on a highway, stars and gas pile up in these waves, compressing clouds until they ignite into stars. The result, a self-sustaining rhythm where the galaxy's own rotation fuels its growth, spiraling outward in a slow-motion fireworks display. But here's what makes the whirlpool extraordinary, its companion. A smaller galaxy, NGC 5195, tugs at its edges, stretching one arm into a distorted streamer. This cosmic tango demonstrates how interactions shape spiral structures, a process our Milky Way knows well. In 4 billion years, when we collide with the Andromeda Galaxy, our orderly disk might churn into similar chaos before settling into a new spiral. Yet for all their majesty, spiral galaxies like the Whirlpool shouldn't exist. According to early models, their delicate arms ought to wind themselves into oblivion within a few rotations. The fact that they endure hints at forces we're still deciphering, perhaps dark matter's invisible scaffolding or magnetic fields threading through the chaos. Which makes the next pattern all the more unsettling, a galaxy that spins backward, flouting every rule of cosmic formation. Imagine a storm so vast it could swallow 4 Earths whole, but instead of swirling in the usual spiral, it's locked into a near-perfect hexagon, its 6 razor-straight sides defying every law of atmospheric chaos. This is Saturn's North Pole, home to the most bizarre weather pattern in the solar system. While hurricanes on Earth rage in circular fury, Saturn's hexagon, discovered by Voyager in the 1980s and later studied by Cassini, stands eerily still, a six-sided sentinel that's endured for at least 40 years. What cosmic physics could sculpt such geometric precision atop a gas giant? One leading theory points to deep-rooted jet streams moving at over 300 miles per hour that shear the storm into angular shapes like a high-speed spinning top. Others suggest the hexagon is a standing wave in Saturn's atmosphere, a rhythmic oscillation frozen in place, much like the vibrations that create intricate patterns in a Chladni plate. But the wildest hypothesis involves something called Rossby waves, planetary-scale ripples that might funnel energy into this polygonal prison. Earth has its own Rossby waves, but our planet's rough terrain and oceans disrupt them. Saturn, with its smooth, gaseous surface, lets these waves run wild, potentially etching hexagons into the sky. What's astonishing isn't just the shape, it's the scale. Each side of the hexagon stretches nearly 9,000 miles, with clouds inside churning at different altitudes and speeds, yet the structure holds. Even stranger, the hexagon changes color with Saturn's seasons, shifting from golden to blue as sunlight waxes and wanes over its 30-year orbit. It's a reminder that weather isn't just local, it's sculpted by a planet's rotation, composition, even its place in space. Yet for all its strangeness, Saturn's hexagon might be a cosmic whisper of something far older, a pattern echoing across light years in the most unexpected places. Just as this storm defies expectations, so too does a distant galaxy spinning in the opposite direction of its neighbors, as if the universe itself enjoys breaking its own rules. If you've ever pressed your palm against a warm light bulb after it's been turned off, you've felt something eerily similar to the universe's oldest glow. The cosmic microwave background, or CMB, is exactly that. The faint afterglow of creation itself, lingering like heat from a cosmic switch flipped nearly 14 billion years ago. But this isn't just ancient radiation. It's a celestial baby picture capturing the universe in its infancy when it was a seething plasma of particles and light. As that plasma cooled, it released a snapshot of its structure, a pattern of tiny temperature variations no larger than 1 part in 100,000. To the unaided eye, it looks like static snow on an old TV, but to cosmologists, those speckles are a Rosetta Stone. What makes these fluctuations so extraordinary is what they reveal about the universe's scaffolding. Those slightly warmer and cooler patches, they're fossilized sound waves, echoes from a time when the cosmos rang like a bell. Picture dropping pebbles into a pond. The ripples spread, collide, and freeze in place as the universe expands. These ripples became the seeds for everything we see today: galaxies, clusters, even the vast cosmic web. The warmer spots mark where matter clumped together, pulled by gravity into the structures we recognize now, while the cooler areas show where space stretched thin. It's as if the universe left us a breadcrumb trail back to its very first moments. Satellites like Planck and WMAP have mapped this glow in astonishing detail, turning statistical noise into a precise blueprint of creation. The patterns align so perfectly with our models of cosmic inflation, a theory suggesting the universe expanded faster than light in its first sliver of time, that it's like finding a manufacturer's stamp on reality itself. Yet mysteries linger. Why do some large-scale fluctuations appear smoother than predicted? Could there be traces of other universes imprinted here? The CMB doesn't just answer questions, it teases new ones. And just as this primordial light guides us backward, another pattern points the way forward, a beacon so reliable, it's used as a lighthouse for intergalactic navigation. Beyond the afterglow lies a celestial metronome, ticking with a rhythm so precise, it rivals atomic clocks. Deep within the constellation Taurus lies a celestial heartbeat, a pulsing remnant of one of history's most violent stellar explosions. The Crab Nebula isn't just a ghostly cloud of gas. It's a cosmic metronome flickering with gamma-ray bursts 30 times every second. Imagine a lighthouse beam sweeping across space, but instead of light, it's a strobe of high-energy radiation precisely timed, never faltering. At its core spins the source of this rhythm, a pulsar, the crushed core of the star that detonated nearly 1,000 years ago. Chinese astronomers in the year 1054 witnessed that explosion firsthand, documenting a guest star so bright it outshone Venus for weeks and was visible even in daylight. Today, we know they were watching a supernova, the death throes of a massive star collapsing into a neutron star no wider than Manhattan, yet denser than a mountain compressed into a sugar cube. That pulsar's spin is so regular it rivals atomic clocks, losing just 1 second every 100 million years. Sailors once navigated by steady stars, but future spacecraft might sync their clocks to these cosmic cadences. Yet the Crab Nebula's true marvel is how it bridges eras. The same explosion that medieval scholars scribbled onto silk scrolls left behind a laboratory for modern physicists. Its swirling filaments, now expanding at 1,000 miles per second, reveal how heavy elements forged in stellar death seed the universe. The pulsar's magnetic field, a quadrillion times stronger than Earth's, accelerates particles to near light speed, creating eerie blue whirlpools of X-rays. It's as if the star's death birthed a new kind of cosmic engine. But while the crab ticks with mechanical precision, another pattern rides across the sky with serpentine grace, a constellation once believed to herald storms, wars, and celestial battles. Far from the orderly pulse of neutron stars, this starry dragon coils through the heavens, its myths as turbulent as the forces that shaped it. Slithering between the Big and Little Dippers, the constellation Draco isn't just a random scattering of stars, it's a celestial serpent coiled eternally around the heavens. Unlike many constellations that rise and set with the seasons, Draco is circumpolar, meaning it never dips below the horizon for observers in northern latitudes. Its winding body snakes around Polaris, the North Star, as if guarding the very axis of the sky itself. Ancient navigators didn't just admire this pattern, they relied on it. Before compasses, sailors used Draco's tail stars Kochab and Firkad as the guardians of the pole, marking time as they circled Polaris like hands on a cosmic clock. Every hour, these stars shift just 15 degrees, turning the night into a readable timepiece for those who knew how to watch. But Draco's mythology burns as brightly as its stars. To the Greeks, it represented Ladon, the 100-headed dragon slain by Hercules in his quest for golden apples. Babylonian astronomers saw it as Tiamat, the primordial chaos monster defeated by the god Marduk. Even Norse legends wove Draco into their tales, naming it Nidhöggr, the serpent gnawing at the roots of the world tree Yggdrasil. These weren't just bedtime stories, they were attempts to explain the constellation's peculiar motion. Unlike other star patterns that seemed to wander, Draco's slow swirl around Polaris made it the perfect symbol of something ancient, watchful, and unchanging. Modern stargazers can still trace this celestial dragon's spine, a chain of moderately bright stars stretching from its diamond-shaped head near Hercules to its tail curled around Ursa Minor. On clear nights away from city lights, the full length of Draco becomes visible, a cosmic river frozen mid-twist. And here's the thrilling part. The star Thuban, nestled in Draco's coils, was once Earth's North Star around 3000 BC when the pyramids of Giza were being built. Precession, that same slow wobble of Earth's axis, has since handed the title to Polaris, but in another 20,000 years, Thuban will reclaim its throne. Constellations aren't just static art, they're actors in a celestial drama unfolding across millennia. Yet for all its grandeur, Draco is just one thread in the sky's tapestry. Not far from its starry scales, another pattern stands in stark contrast, not a serpent, but a cross etched into the heavens with such precision it feels almost deliberate. This isn't just a navigational aid, it's a celestial marker tying together astronomy, faith, and the human hunger for meaning in the stars. While northern travelers orient themselves by the Big Dipper's familiar ladle, those below the equator rely on a far more compact but no less powerful celestial guide, the Southern Cross. This tiny, diamond-bright constellation packs a navigational punch far beyond its size. Just 4 main stars form its cross shape, yet for centuries, sailors have used it like a compass needle pointing true south. Here's how it works. Imagine drawing a line down the cross's long axis and extending it 5 times its length. That invisible path lands you near the south celestial pole, the anchor around which the entire southern sky rotates. Unlike Polaris, which sits almost directly above the North Pole, the southern pole has no bright star to mark it. The cross fills that gap, becoming a cosmic signpost when other references vanish into the horizon. But this constellation isn't just a tool, it's a cultural touchstone. To the Wardaman people of Australia, the cross represents a stingray, its stars tracing the creature's tail as it swims through the Milky Way's celestial river. European explorers, meanwhile, saw it as a divine symbol, sewing it onto flags and mapping it onto colonial crests. Yet both interpretations share something profound. They recognized this pattern as a keeper of direction, a fixed point in the turning sky. Even Antarctica's earliest explorers, like Shackleton, calibrated their sextants by its light. What's fascinating is how the cross's role mirrors yet flips the Big Dipper's northern duties. While the Dipper's pointer stars arc toward Polaris, the cross's longer beam leans southward. Both act as celestial pivots, but where the Dipper's 7 stars sprawl across a wide swath of sky, the cross's compact form makes it ideal for low visibility conditions. Mariners in stormy southern seas often found its tight geometry easier to spot than the Dipper's fainter arcs. Yet the cross isn't alone in its journey. Just beside it flows the Milky Way's brightest segment, a starry river so dense it casts shadows on the ground under pristine skies. This luminous band isn't just a backdrop, it's the next piece of the cosmic puzzle, a sprawling highway of starlight that ties the southern sky together. Stretching across nearly 2 billion light-years of space lies one of the universe's most unsettling mysteries, a yawning expanse of nothingness so vast it defies explanation. Astronomers call it the Eridanus Supervoid, a blisteringly cold desert in the cosmic background radiation where galaxies are strangely scarce. Unlike typical voids, which are mere pockets of emptiness, this one is monstrous, large enough to swallow thousands of Milky Ways without a trace. The temperature here is just a fraction cooler than the rest of the cosmos, but that faint dip in heat screams of something profoundly off. Some scientists suspect this void might be the imprint of a collision with another universe, a bruise left behind when our cosmos brushed against an unseen neighbor in the multiverse. Others argue it's simply a statistical oddity, an illusion created by gaps in our observations. But the eerie truth, even our best simulations of cosmic structure struggle to explain how such a void could form naturally. It's as if the universe itself left a blank page in its own story, daring us to decipher it. Yet for all its strangeness, the Eridanus Supervoid isn't the only pattern etched into the fabric of reality. Not far from this cosmic ghost town, another enigma waits, the largest single structure ever discovered. A galactic filament so vast, it rewrote our understanding of the universe's architecture. If the void is a whisper of absence, this next pattern roars with presence. Hidden among the countless galaxy clusters that dot the observable universe, one structure stands out for its uncanny, almost unsettling alignment. Astronomers call it the Finger of God, a sprawling formation where galaxies stretch in a near-perfect line that appears to point directly at Earth. At first glance, it seems like an impossible coincidence or something more deliberate. How could countless galaxies, separated by millions of light years, arrange themselves as if tracing an arrow toward us? The truth lies in a cosmic illusion known as the Kaiser effect. As light from these distant clusters races toward us, it gets warped by the gravitational pull of invisible dark matter, filaments, threads of unseen mass weaving through the universe like scaffolding. What looks like a deliberate alignment is actually a trick of perspective, a mirage created by matter we can't see bending the path of light we can see. Yet for all its scientific explanation, this phenomenon still stirs deeper questions. Some theologians have pondered whether the finger of God might be more than just physics, a signpost in the heavens echoing ancient beliefs that the cosmos communicates meaning. Scientists, meanwhile, see it as proof of dark matter's invisible architecture, a blueprint of the universe's hidden framework. Both perspectives share something profound: the human instinct to find patterns, whether through equations or symbolism. But if this cosmic arrow feels grand, the next pattern is intimate, a celestial cradle where stars are born in swirling clouds of gas and dust. Not far from the finger, another structure pulses with the raw energy of creation itself, sculpting new suns from chaos, rising from the cosmic dust like a celestial cathedral. The pillars of creation stand as one of Hubble's most breathtaking discoveries. These towering columns of gas and dust, stretching over 5 light-years tall, aren't just a stunning portrait, they're a stellar nursery where new suns are born. Nestled within the Eagle Nebula, these pillars glow with the light of infant stars still tucked inside their dusty cocoons. Ultraviolet radiation from nearby massive stars carves into the gas, sculpting it into those iconic, finger-like shapes while also triggering the collapse of denser pockets into newborn stars. It's a cosmic cycle of destruction and creation, where the same forces that erode the pillars also breathe life into the next generation of stars. But here's the haunting twist: by the time Hubble captured this image in 1995, the pillars might have already been gone. Shockwaves from a nearby supernova likely blasted them apart 6,000 years ago, their light only reaching us now due to the vast distance. The very stars they birthed probably annihilated their creators, a poetic reminder that beauty in the cosmos is often fleeting. Yet this cycle isn't unique. Far beyond the Eagle Nebula, another kind of dance unfolds, one where entire galaxies whirl around each other in a gravitational embrace. Unlike the solitary pillars, these galactic partners sculpt each other over eons, trading stars and gas in a slow-motion performance that reshapes them both suspended in the cosmic dark. Two titans drift toward each other in a slow-motion ballet that will reshape the night sky forever. The Andromeda Galaxy, our closest galactic neighbor, is hurtling toward the Milky Way at 250,000 miles per hour, pulled by gravity's unrelenting hand. But don't panic, this isn't a catastrophic crash. Think of it as a cosmic waltz where two spiral galaxies entwine over billions of years, trading stars like partners in a dance rather than shattering in chaos. Advanced simulations reveal how the encounter will unfold. First, Andromeda's halo of hot gas will brush against ours, sparking a fireworks display of newborn stars. Then, their spiral arms will stretch into luminous tidal streams, painting the sky with bridges of stardust. Here's the reassuring truth: galaxies are mostly empty space. The average distance between stars is so vast that direct collisions are vanishingly rare. Our solar system might get flung to the outskirts of the merged galaxy, but the planets will remain unscathed. Future Earthlings, or whatever species inherits the planet, will witness something extraordinary. Andromeda growing from a faint smudge to a sprawling disk, eventually merging with the Milky Way into a single, football-shaped galaxy astronomers nickname Milkdromeda. Familiar constellations will dissolve, replaced by new patterns woven from two stellar populations finally united. Yet this grand merger is just one thread in a larger tapestry. Beyond individual galaxies lies the cosmic web, a labyrinth of dark matter and gas connecting all visible structures in the universe like neurons in a celestial brain. Filaments of invisible matter stretch between galaxy clusters, funneling gas into hubs where new stars ignite. Simulations reveal this web isn't random. It's a fossilized echo of the universe's first seconds, when quantum ripples inflated into vast scaffolding. The same forces pulling Andromeda toward us also built these threads, binding the cosmos in a hidden lattice of gravity. Zoom out far enough, and the universe reveals its grandest design not as scattered stars or lone galaxies, but as an intricate web of luminous threads stretching billions of light-years across the void. This colossal architecture, known as the cosmic web, looks eerily like a neural network, filaments of galaxies braided together by gravity, intersecting at dense hubs where galaxy clusters blaze like cities in the night. What's astonishing isn't just the scale of this structure, but the fact that most of its architects remain invisible. Dark matter, that enigmatic substance we can't see but know exists, acts as the scaffolding, its gravitational pull drawing ordinary matter into these sprawling highways of light. Without it, the universe might have remained a formless sea of gas. Picture the cosmic web as a tapestry woven from three ingredients: threads, nodes, and voids. The threads are galaxy filaments, delicate strands of thousands of galaxies strung along dark matter's invisible rails. Nodes are where these filaments meet, bustling metropolises like the Virgo cluster, home to over 1,000 galaxies packed into a space just 20 million light-years wide. And between them, vast deserts like the Boötes Void, regions so empty they could fit 60 Milky Ways in a row without a single star. It's a structure both elegant and chaotic, like foam bubbles frozen mid-pop. Yet for all its grandeur, this web is fragile. The same gravity that built it is also tearing it apart as dark energy accelerates the universe's expansion. One day, distant filaments will vanish beyond our cosmic horizon, their light stretched too thin to ever reach us, but for now, they offer a roadmap to the universe's past, a fossilized imprint of sound waves from the Big Bang, preserved in the spacing of galaxies like grooves in a cosmic record. And just as this web connects the universe in threads, another pattern loops it into a perfect circle, a rare, almost artificial-looking ring of galaxies so vast it shouldn't exist under conventional physics. Amid the chaos of colliding galaxies and spiraling star clusters, one celestial wonder stands out for its almost surreal symmetry: Hoag's object. Seen face-on through telescopes, this galaxy floats like a cosmic bullseye, its luminous blue ring of young stars encircling a golden core with eerie precision. What makes it so baffling is what's not there. Most ring galaxies, like the cartwheel, form when a smaller galaxy punches through a larger one, sending shockwaves of star formation rippling outward in a ring. But Hoag's object shows no signs of a collision, no warped disks, no debris trails, just a near-perfect circle suspended in space. How does nature sculpt such flawless geometry without violence? One theory suggests a rare instability in the galaxy's original disk caused stars to migrate inward and outward, leaving the ring behind like a stellar ripple frozen in time. Others propose a long-ago encounter with another galaxy so gentle it left no scars, gently tugging material into orbit. Even stranger, peering deeper into the ring reveals another, fainter ring farther out, as if the galaxy layered itself like celestial tree rings. It's a puzzle that challenges our assumptions about galactic evolution, proving the universe sometimes prefers elegance over chaos. Yet Hoag's object isn't alone in its artistry. Across the cosmos, galaxies like NGC 6028 wear similar luminous hoops, though none with the same pristine symmetry. These formations hint at a hidden diversity in how galaxies age, some torn apart by collisions, others reshaping themselves with quiet grace. But if Hoag's object is a cosmic bullseye, Another pattern flutters through the void with delicate, almost living structure. Far from the stillness of rings, this celestial butterfly spreads its glowing wings in a nebula where newborn stars stir the gas into shapes that feel almost alive. Drifting through the constellation Scorpius like a phantom caught in starlight, the Butterfly Nebula unfurls its iridescent wings across space, a masterpiece sculpted by dying sun. This isn't a serene cloud of gas. It's a celestial Rorschach test with twin jets of superheated material screaming outward at 600,000 miles per hour, etching perfect, symmetrical arcs into the cosmos. At its heart lies a white dwarf, the collapsed core of a star that once resembled our sun, now frantically pumping ultraviolet radiation into its own funeral shroud. The result, a glowing Rorschach blot spanning 3 light years where every color tells a story: blue for oxygen, red for nitrogen, green for hydrogen, a chemical fingerprint of the star's final act. What's astonishing isn't just the nebula's beauty, but the precision of its chaos. Most planetary nebulae, a misnomer from early astronomers who thought they resembled planets, bubble outward in ragged spheres. The butterfly's bipolar jets, however, slice through space with knife-like symmetry, a phenomenon tied to the dying star's spin and magnetic fields. Imagine a spinning garden hose. The star's rotation flings material from its poles, while its magnetic fields corkscrew the ejector into those ethereal wings. This level of order emerging from stellar death hints at hidden laws governing even the universe's most violent transformations. Yet the Butterfly Nebula is more than a tombstone, it's a time capsule. The layers of gas expelled over millennia reveal the star's life story like tree rings. Heavy elements like carbon forged in its core during its red giant phase now drift into space, destined to be recycled into future stars, planets, perhaps even life. Every butterfly-winged nebula we spot is proof that stars don't just die, they scatter the ingredients for new beginnings. And while this stellar phoenix paints the void with fire, another eye-like pattern gazes back from the darkness, one where gravity itself warps light into a perfect cosmic illusion. Gazing out from the constellation Aquarius like a cosmic eye, the Helix Nebula stares back at us with an eerie, almost sentient glow. Known to some as the Eye of God, this donut-shaped cloud of gas spans nearly 3 light-years, close enough for backyard telescopes to spot its ghostly halo under dark skies. What makes it so haunting isn't just its appearance, but the inevitability it represents. This is what our own sun could become in about 5 billion years. Amateur astronomers have captured stunning portraits of the helix, revealing delicate nitrogen tendrils glowing red and oxygen filaments blue-green radiating outward like a celestial iris. At its center, the nebula's white dwarf star, once a sun-like giant, now shines with ultraviolet intensity, lighting up its expelled outer layers like a flashlight beam through fog. Unlike the Butterfly Nebula's violent jets, the helix's structure is quieter, its gases expanding in slow, concentric waves that resemble ripples from a pebble dropped in water. Yet behind that serenity lies a warning. Even stars die with dignity, unraveling into space to seed future worlds. For stargazers, the helix offers rare insight into our solar system's fate. When our sun exhausts its fuel, it too will shed its skin, leaving behind a glowing core ringed by shimmering debris. Distant civilizations might one day gaze at that remnant as we now study the helix, a monument to stellar mortality written across the sky. But not all stars fade gently. Just as the helix whispers of quiet endings, another pattern screams of celestial violence, a supernova remnant so turbulent, it stitches chaos into the fabric of space itself. Stretching across the constellation Cygnus like shattered stained glass, the Veil Nebula spins death into art. This delicate web of ionized gas spanning 110 light-years isn't just debris from a star that exploded 8,000 years ago. It's a masterclass in cosmic craftsmanship. Zoom in and you'll see filaments so fine they resemble lace. They're glowing tendrils of oxygen blue, hydrogen red, and sulfur green, woven together by shock waves racing outward at 500,000 miles per hour. It's as if the universe took a stellar explosion, one of its most violent events, and embroidered the aftermath into something hauntingly beautiful. What's mesmerizing is how physics mirrors art here. The nebula's intricate threads form where shockwaves plow through cooler interstellar gas, like ripples in a pond freezing mid-motion. Each twist and knot reveals the turbulence of that ancient detonation, preserved in luminous detail. Compare it to earthly lace-making. Just as needles pull threads into patterns, shockwaves tug and braid stellar material into these radiant filaments. Even the colors tell a story. Oxygen glows where temperatures soar hottest, while hydrogen traces the cooler, outer fringes of the blast wave. Yet the veil isn't just a static relic. Hubble's time-lapse observations show sections of the nebula still expanding, their structures evolving faster than expected. Some filaments vanish within decades, while others brighten as they collide with denser gas, a proof that stellar death isn't an endpoint but a transformation. From this celestial lacework, the cosmos offers another kind of ephemeral beauty, one not born from destruction but from stellar cradles. Not far from the veil's shattered elegance, a different nebula blooms like a rose in the void, its petals unfurling under the light of newborn stars. Somewhere in the constellation Monoceros, a cosmic flower unfurls its petals, not in soil but in a vast cloud of glowing hydrogen. The Rosette Nebula stretches over 50 light-years wide, its delicate loops of crimson gas illuminated from within by the fierce radiation of newborn stars. At its heart, the star cluster NGC 2244 blazes like a bouquet of diamonds, their stellar winds sculpting the surrounding nebula into a shape that mirrors Earth's most intricate roses. It's no accident this structure feels alive. Every twist of gas is a testament to the same cycle that fills gardens with blossoms each spring. Stars are born, they flood their nursery with light and heat, and eventually they'll scatter the seeds of future suns in their wake. What makes the Rosette extraordinary isn't just its beauty, but its violence. Those ethereal petals are actually shock fronts where radiation from young stars collides with cooler molecular clouds, making hydrogen fluoresce in that iconic red hue. Peer deeper and you'll spot dark tendrils of dust threading through the glow, not just empty space but the raw material for planets, even life. Astronomers have spotted hundreds of protostars here, some still wrapped in dusty cocoons, others already burning bright enough to carve new cavities in the nebula's folds. Yet for all its fire, the Rosette whispers a gentler truth. Destruction and creation are two sides of the same cosmic coin. The same stellar winds eroding the nebula today are compressing nearby gas pockets, triggering the next wave of star formation. It's a celestial Ouroboros, a snake eating its own tail, if that tail was made of starlight and dust. As if painted to contrast the Rosette's organic swirls, another pattern gleams nearby, a cluster so densely packed with stars, it resembles a jewel box spilled onto black velvet. Unlike the nebula's slow unfurling, this next spectacle blazes with the tight, precise symmetry of a cosmic crown. Nestled within the Southern Cross lies a celestial treasure chest that defies the monochrome expectations of the night sky, the Jewel Box Cluster. Officially catalogued as NGC 4755, this dazzling group of stars erupts in a fireworks display of sapphire blues, ruby reds, and topaz golds, as if the cosmos dipped its brush into a palette of stellar fire. The secret behind this chromatic spectacle: temperature. Unlike the uniform white pinpricks we often see, these stars burn at wildly different intensities. Blue-white supergiants blaze at over 30,000 degrees, while cooler red giants simmer around 3,000, their light stretching across the spectrum like notes in a cosmic chord. The cluster's poetic name traces back to John Herschel, the 19th century astronomer who described it as a casket of variously colored precious stones through his telescope. Modern observations reveal even grander details. Around 100 stars packed into a space just 20 light-years wide, with the central triple star system, Kappa Crucis, shining like a diamond at its heart. For Southern Hemisphere stargazers, spotting the jewel box is simple. Just glance beside the cross's blue-white star Beta Crucis, where it sparkles like a handful of gems tossed onto black velvet. Yet for all its brilliance, the jewel box hints at a deeper truth. Stars aren't solitary actors, but siblings born from the same cosmic womb. Their varied colors tell the story of stellar evolution, with some members already ballooning into red giants while others remain blistering blue infants. This multi-generational family portrait offers a snapshot of how star clusters age, some stars racing through their lives, others biding their time. As we marvel at this glittering assembly, another pattern lurks in the void, one that swallows light rather than radiating it. Beyond the jewel box's radiant banquet lies a cosmic shadow, a place where stars go missing and the rules of visibility twist into something unsettling lurking in Neptune's deep blue atmosphere like a shadowy bruise. The great dark spot was a storm so vast it could swallow Earth whole until it simply vanished. When Voyager 2 first spotted this tempest in 1989, scientists were stunned. Here was Neptune's answer to Jupiter's Great Red Spot, a swirling vortex of frigid methane clouds raging at 900 miles per hour. Yet unlike Jupiter's centuries-old storm, Neptune's marquee feature disappeared within years, leaving astronomers puzzled. How could a planetary-scale hurricane simply dissolve? The answer lies in the brutal physics of ice giants. Neptune's supersonic winds, fueled by internal heat rather than sunlight, churn its atmosphere into chaos. Storms here aren't self-sustaining like Jupiter's. They're transient eruptions boiling up from the depths before being shredded by those relentless jet streams. This vanishing act reveals a deeper truth about cosmic patterns. Some are fleeting brushstrokes, not permanent fixtures. Saturn's hexagonal storm endures, Jupiter's spot shrinks but persists, while Neptune's scars come and go like ghosts. Planetary atmospheres are palettes where fluid dynamics paint with different rules. Jupiter's stable layers allow long-lived storms, while Neptune's turbulent depths recycle features like a cosmic etch-a-sketch. Even Earth plays by its own rules. Our hurricanes fade within weeks, yet the jet stream's waves persist for months. But if Neptune's storms are ephemeral, another cosmic phenomenon bends the rules of visibility entirely, not through disappearance but through illusion. Far beyond our solar system, gravity twists light into a perfect deception, creating celestial mirages that defy conventional observation. Somewhere in the constellation Pegasus, the cosmos plays a trick of light so perfect, it could have been pulled straight from Einstein's notebooks. Meet the Einstein Cross, a single quasar, billions of light-years away, whose light splinters into 4 identical images arranged like a celestial compass around a foreground galaxy. It's not an illusion or an error, it's gravity bending space-time itself into a lens. Here's how the magic works. That intervening galaxy's immense mass warps the fabric of space around it, curving the quasar's light like water, bending the path of a straw in a glass. The result, a cosmic mirage where one object appears multiple times, stretched and mirrored by gravity's invisible hand. Astronomers call this gravitational lensing, and it's one of relativity's most dazzling confirmations, proof that mass doesn't just attract objects, it twists the very stage they move on. What makes the Einstein Cross so special isn't just its symmetry, it's its precision. The 4 quasar images flicker in perfect sync, since they're all views of the same object arriving via slightly different cosmic detours. By studying their brightness variations, scientists can map the galaxy's dark matter halo, weighing what we can't see using distortions in what we can. It's like decoding a fingerprint left by the universe's hidden architecture. Yet even as this lensed light reveals secrets, another kind of cosmic messenger travels much slower, not warped by gravity but reverberating through time. Far beyond Einstein's cross, the aftermath of a stellar explosion lingers not as an image, but as an echo in the vast emptiness between stars. A celestial time machine flickers to life, not with a bang, but with a whisper. V838 Monocerotes, an unassuming star in the constellation Monoceros, became an overnight cosmic celebrity in 2002 when it erupted without warning. But this wasn't a typical supernova or a garden-variety flare. Instead of blasting material into space, V838 Mon briefly became 600,000 times brighter than our Sun, then just as mysteriously faded, not by collapsing, but by swelling into a red supergiant in mere weeks. The real magic, though, happened around it. As the star's light raced outward at, well, the speed of light, it illuminated concentric shells of dust that had lingered unseen for decades, like a lighthouse beam sweeping through fog. The effect is one of nature's most breathtaking illusions, a light echo. Imagine dropping a stone into a still pond. Ripples expand outward, each ring marking where the pebble's energy touched the surface. V838 Mon's light behaves similarly. The dust shells act as cosmic pond water, reflecting the star's flash with a delay that betrays their distance. By tracking how the echo propagates, astronomers can triangulate the star's location with precision, turning physics into a measuring tape for the universe. It's like watching history unfold in reverse. First, the star's outburst reaches us. Then its reflection bounces off dust from 10 years ago, then 20, painting a time lapse of its own past. What makes V838 Mon even stranger is what it didn't do. Most dying stars shed their outer layers in a planetary nebula or explode as supernova. This one simply puffed up, then receded, leaving astronomers debating whether it merged with another star or devoured unseen planets. Its tantrum, though brief, gifted us something rare, a three-dimensional map of its surroundings, proving even stellar misfits have cosmic value. Yet if V838 Mon's echo feels like a fleeting melody in the void, another pattern thrives on something far more primal, not reflection but consumption. Not far from this stellar oddity, a galaxy hides in plain sight, one that doesn't just neighbor others, it eats them. Pattern 24, the Canis Major Dwarf, a galaxy slowly devoured, a silent feast, unfolds just 25,000 light-years from Earth, hidden behind the curtain of stars in our own Milky Way. The Canis Major Dwarf galaxy, once a small but independent cosmic island, is now slowly unraveling, stretched into luminous rivers of stars by our galaxy's relentless gravity. This isn't a fast or fiery collision. It's a drawn-out cosmic digestion where tidal forces pull the dwarf galaxy apart like taffy, scattering its stars into long, looping streams that orbit invisibly around us. What's left of Canis Major is a ghostly skeleton, just a few dense patches of stars still clinging together, surrounded by vast, arching tendrils that have already been absorbed into the Milky Way's outer halo. These tidal streams are more than debris, they're celestial breadcrumbs marking the galaxy's final orbits before total assimilation. Stargazers unknowingly look right through them every night. These galactic remnants blend seamlessly into the background of the Milky Way, camouflaged until revealed by infrared surveys and precise stellar mapping. Yet this slow-motion demolition isn't just destruction, it's renewal. The same forces tearing Canis Major apart are seeding our galaxy with fresh stars, metals, and gas, fueling future generations of suns. Galactic mergers aren't exceptions, they're the rule. Even our Milky Way owes its spiral arms and central bulge to past collisions, growing bigger and more complex with every consumed companion. One day, Andromeda will do the same to us, rewriting the night sky entirely. But for all the violence of galactic evolution, the next pattern defies explanation, not a stream or a spiral, but a cosmic question mark hanging in the void. Far beyond the wreckage of Canis Major, something even stranger curls through the darkness, as if the universe itself paused to wonder, hanging in the constellation Cygnus like a celestial punctuation mark. The question mark nebula taunts astronomers with its uncanny shape, a glowing curve of gas crowned by a bright knot, perfectly mimicking the symbol of inquiry itself. This isn't some digital artifact or optical illusion. It's a real cosmic structure sculpted by the same forces that carve all nebulas, stellar winds, and radiation. Yet, unlike its symmetrical cousins, this formation seems to revel in ambiguity. Is it a dying star's ejected shell caught mid-expansion, a chance alignment of interstellar clouds? Or perhaps the universe's playful nod to human curiosity? The truth lies in the physics of chaos. The nebula's hooked shape likely formed when a massive star's solar winds, particles streaming outward at millions of miles per hour, collided with denser pockets of interstellar gas, carving cavities and leaving ridges like waves against a rocky shore. Radiation from nearby stars then ionized the gas, making it glow in hues of red and blue. What's fascinating isn't just the shape, but how it challenges our instinct to categorize. Nature rarely draws with perfect geometry, yet here, amid the turbulence, emerges a form that feels almost intentional. For backyard stargazers armed with telescopes, the question mark nebula offers more than science. It's a Rorschach test for the cosmos. Some see a shepherd's crook, others a celestial seahorse. Ancient cultures might have woven it into creation myths or omens. That's the magic of such patterns. They invite us not just to observe, but to interpret, bridging the gap between data and wonder. As this enigmatic nebula lingers in Cygnus, another pattern whispers of kinship rather than mystery. Not far away, a cluster of stars huddles together not by accident but by birth, a stellar family bound by gravity and shared history, tracing lineages far older than human civilization, nestled in the constellation Taurus like a glittering arrowhead. The Pleiades cluster isn't just another smattering of stars, it's a celestial time capsule hovering a mere 150 light-years from Earth. Close enough that its brightest members paint a distinct V in the night sky. Unlike distant star clusters that appear static, the Pleiades feels almost alive. Its stars drift together through space like a school of fish, sharing a common velocity and origin. Ancient Greeks mythologized these stars as rain-bringing nymphs, weeping for their fallen brother Hyas, but modern astronomers see something far more practical, a cosmic yardstick. Because the Pleiades is so relatively close, its precise movements help calibrate distances across our galaxy, acting as a stepping stone to measure even farther reaches of the universe. What makes this cluster truly fascinating is its slow unraveling. Gravity no longer binds the Pleiades tightly, its stars are gradually scattering, tugged by the Milky Way's tidal forces. Over millions of years, that iconic V will stretch and distort, its stars blending into the galactic background. For now, though, stargazers can spot its brightest member, the orange giant Aldebaran, anchoring the bull's eye. Though ironically, Aldebaran isn't part of the cluster at all. It's a foreground interloper, floating just 65 light-years away while the true Pleiades stars glow twice as distant. Yet the Pleiades isn't just a pretty asterism. Its star's composition, rich in metals like iron, hints at a violent past. This cluster likely formed from a gas cloud seeded by earlier supernova explosions, their debris recycled into new suns. Every time you trace that V, you're glimpsing a stellar generation born from the ashes of its predecessors. As these sibling stars continue their slow-motion dispersal, another cosmic beacon pulses with unwavering reliability, not drifting but spinning with metronomic precision, guiding explorers across both sea and space. Cutting through the cosmic darkness like a lighthouse beam sweeping across a stormy sea, the Lighthouse Nebula pulses with an eerie, rhythmic glow. At its heart lies a neutron star spinning nearly 7 times every second, so dense, a single teaspoon of its material would weigh billions of tons on Earth. But what makes this celestial beacon extraordinary isn't just its speed. It's the twin jets of high-energy X-rays blasting from its poles, visible only through specialized telescopes. Each rotation flings these particle beams across space like a cosmic strobe light, illuminating surrounding gas clouds with bursts of radiation that mimic the steady flash of a navigational beacon. Ancient mariners once steered by earthly lighthouses to avoid treacherous shores. Today, astronomers use pulsars like this one as interstellar guideposts. Their predictable flashes, some as precise as atomic clocks, help map the galaxy's structure and even test Einstein's theory of relativity. The Lighthouse Nebula's pulses are so regular, they could theoretically help spacecraft navigate the void between stars, turning these dead stars into signposts for future explorers. Yet for all its mechanical precision, this nebula is anything but static. Its jets carve through surrounding gas like a sculptor's chisel, creating shock waves that ripple outward in glowing filaments. Somewhere in those turbulent currents, matter and energy collide in a dance that's both destructive and creative, a reminder that even in the darkest corners of space, light finds a way to etch its mark. As this spinning sentinel keeps watch, another cosmic phenomenon takes the opposite approach, not marking its place with flashes, but vanishing into the background like a celestial chameleon. Where the Lighthouse Nebula demands attention, our next pattern thrives on camouflage, reshaping itself so thoroughly that astronomers once overlooked it entirely. Pattern 28. The chameleon dark cloud stellar nurseries wrapped in shadow high above the southern sky, where constellations flicker like distant campfires, lies a patch of nothingness so profound it seems the universe forgot to fill it in. These aren't empty voids, they're the chameleon dark clouds, colossal blankets of dust and gas so thick they swallow starlight whole. To the naked eye, they appear as mere gaps in the Milky Way's glow, but peer deeper with infrared telescopes, and the truth emerges. These shadows are cosmic cradles, packed with the raw ingredients for new stars. Inside these frigid clouds, temperatures hover just a few degrees above absolute zero. Molecules of hydrogen and carbon monoxide huddle together, shielded from prying eyes by grains of silicate and ice. Gravity works in slow motion here, tugging weakly at these particles over millions of years until eventually pockets collapse into dense knots. When they do, the heat of compression ignites nuclear fusion and a star flickers to life. It's a process hidden behind curtains of dust, visible only to instruments that see beyond visible light. What's mesmerizing is how these holes in the sky deceived early astronomers. Without modern technology, dark clouds like chameleon were once mistaken for empty space. Now we know they're anything but. Their dust isn't obscuring the universe, it's forging it. Every speck will one day become part of planets, comets, or even the chemistry of life itself. Yet as these clouds quietly assemble stars, another spectacle unfolds nearby. One that doesn't hide its brilliance but flings it across the galaxy in great glittering arcs. Where chameleon conceals, this next pattern erupts, turning the cosmos into a fountain of light and motion. Rising from the heart of our galaxy like twin geysers of pure energy, the Fermi Bubbles stretch an astonishing 50,000 light-years above and below the Milky Way's disk, a cosmic hourglass etched in gamma rays. Discovered just over a decade ago by NASA's Fermi telescope, these colossal structures glow with the aftermath of some unimaginable event. their faint radiation painting the sky in wavelengths invisible to human eyes. They aren't just random flares, they're a fossilized explosion, a signature of violence written into the fabric of our galactic backyard. But what could have unleashed such fury? The prime suspect sits at the Milky Way's core, Sagittarius A, our supermassive black hole. Astronomers theorize these bubbles might be the aftermath of a past feeding frenzy, a moment when the black hole gulped down a colossal meal of gas, stars, or even dark matter, belching out jets of energy that inflated these gargantuan lobes. Supporting this idea are the bubble's edges, sharp as knife cuts, suggesting a sudden, cataclysmic release rather than a slow leak. Yet alternative explanations abound. Could they be remnants of a burst of star formation, with thousands of supernovae detonating in unison, or evidence of dark matter particles annihilating one another in the galaxy's heart? The debate rages because these bubbles defy expectations. Nothing in our current models of galactic behavior easily explains their sheer scale or symmetry. Scale is key here. Imagine holding a dinner plate edge onto your eye. The Milky Way's disk would appear about that wide, while the Fermi bubbles would tower above and below it like skyscrapers beside a sidewalk. Animations of these structures reveal their true majesty, halos of energized particles, woven through with magnetic fields, lingering like smoke long after the cosmic fire has faded. They're a reminder that galaxies aren't static. They breathe, erupt, and evolve, with our own Milky Way hiding chapters of its history in these ghostly imprints. Yet for all their violence, the Fermi bubbles pale in comparison to another enigma, one that loops the cosmos into a perfect circle, a structure so vast it challenges our understanding of space itself. Pattern 30. The Hoag's object twin, a cosmic echo defying expectations. While Hoag's object stunned astronomers with its pristine ring, another galaxy, PGC 100,000, floats quietly in the constellation Sculptor, mirroring the same impossible perfection. At first glance, it's a doppelganger, a golden core embraced by a sapphire ring separated by an eerie void. Yet this twin isn't merely a copy, it's a cosmic riddle with its own twists. Unlike Hoag's serene symmetry, PGC's ring flickers with clusters of young stars, suggesting recent bursts of formation. How could two galaxies so far apart, 500 million light-years, separate them arrive at nearly identical designs through different paths? Theories scramble to explain. Some propose these rings are remnants of ancient collisions, where smaller galaxies punched through the larger ones like bullets through smoke, leaving ripples of star birth in their wake. Others suggest internal instabilities, gas spiraling outward until it condenses into a radiant loop. But here's the kicker: neither scenario fully accounts for the voids between these galaxies' cores and rings. It's as if the universe skipped a step in its usual playbook, leaving astronomers to wonder if dark matter or unseen magnetic fields sculpted these gaps. What makes these twins truly humbling is their defiance of time. Hoag's object and PGC exist in different eras, yet they're frozen in the same improbable pose, like two dancers in separate universes mirroring the same choreography. Their repetition hints at hidden rules, patterns so universal they transcend individual galaxies. Yet for all their beauty, ring galaxies are cosmic anomalies. Far more common are the relics of stellar demise, places where stars don't dance but rest. Beyond these celestial halos lies a graveyard of another kind, one where the universe's most violent deaths left behind tombstones that pulse with life, hovering in the constellation Draco like a celestial jewel. The Cat's Eye Nebula glows with an otherworldly symmetry, its concentric rings of gas peeling away like the layers of an onion frozen mid-unraveling. This isn't just another dying star, it's a stellar autopsy captured in luminous detail. Each of those delicate shells represents a violent episode in the star's death throes, expelled in pulses separated by thousands of years. Imagine a clockwork explosion. As the star convulses, it sheds its outer layers in rhythmic outbursts, leaving behind a fossil record of its final millennia, written in glowing hydrogen and oxygen. What's startling isn't just the nebula's beauty, it's the precision of its chaos. Most planetary nebulae bubble outward in ragged spheres, but the cat's eye's intricate loops and knots suggest something stranger. Magnetic fields spinning like cosmic lassos may have shaped these ejections into perfect rings, while a companion star, now vanished, could have stirred the gas into those hypnotic swirls. Hubble's close-ups reveal even finer details, shockwaves rippling through the shells, and a central star so hot it makes the surrounding gas fluoresce like neon. This is stellar death as high art where physics and aesthetics collide. Yet those layers are more than just a light show. They're a timeline. By measuring the spacing between shells, astronomers can estimate the star's pulse rate, roughly one eruption every 1,500 years. The outer rings, stretched and faded, whisper of quieter final breaths, while the inner turmoil hints at the star's desperate struggle to stabilize before collapse. It's a narrative etched in gas, one that mirrors the life cycles of countless suns, including our own. As the cat's eye slowly dissipates into the void, its elegance gives way to something far more primal, a pattern not of artistry but of raw, unfiltered force. Beyond these dying whispers lies a structure so immense, it bends the very fabric of the cosmos, weaving galaxies into a design that dwarfs all others. Pattern 32. The cosmic web's nodes where the universe's threads converge at the grandest scale imaginable. The cosmos reveals its final masterpiece, not as scattered stars or lone galaxies, but as an intricate tapestry woven from filament. Light and shadow zoom out far enough and you'll see it. Galaxies huddled together in dense, glittering knots, connected by vast tendrils of gas and dark matter. These intersections where the cosmic web's threads meet aren't just random gatherings. They're bustling hubs of gravity and energy, the crossroads where the universe orchestrates its grandest collaborations. What's astonishing isn't just the scale, it's the familiarity. These galactic nodes mirror the neural networks of the human brain, with galaxies replacing neurons and cosmic filaments acting like synapses. Both systems thrive on connection. In the brain, electrical pulses create consciousness. In the cosmos, gravity sculpts the pathways for stars to form and galaxies to evolve. Even ecosystems on Earth echo this design: mycorrhizal fungi linking trees in a subterranean web, or coral reefs branching into intricate colonies. The universe, it seems, has a favorite blueprint for complexity, repeating it from the microscopic to the galactic. Inside these nodes, the action is relentless. Galaxy clusters like Abell 1689, home to thousands of galaxies bound by gravity, become cosmic laboratories. Here, collisions between galaxies ignite bursts of star formation, while supermassive black holes at their cores churn out jets of energy powerful enough to sculpt entire galactic neighborhoods. The gas between galaxies isn't empty space, it's a searing plasma hotter than the sun's core, vibrating with the echoes of ancient collisions. Yet amid the chaos there's harmony. Each interaction, each merger, feeds the cycle of creation and destruction that keeps the universe evolving. Perhaps the most profound realization is how these nodes bind together everything we've explored. The Fibonacci spirals of galaxies, the rhythmic pulses of pulsars, even the fleeting beauty of nebulae, they're all notes in a symphony composed by gravity and time. The cosmic web's nodes are the crescendos, places where the universe's patterns amplify and intertwine. From the tiniest snowflake to the largest galaxy cluster, nature speaks the same language: connection, rhythm, and the endless dance of chaos giving birth to order. So what does it all mean? Maybe the universe isn't just a collection of objects, but a living, self-organizing system, a symphony where every star, every galaxy plays its part. And if that's true, then gazing at the night sky isn't just observation. It's listening to the deepest music of all.